In this episode of Finno-Ugric Machining, we are going to make the intake manifold for this rotary vane compressor. Well, it will be a sort of a simple milling job. The material is Uddeholm Sleipner tool steel, which is a total overkill for this project. But, I just happen to have a suitable sized chunk of that material, so we will be using that. Okay? So, it will be mill. First, I will clean up the faces of this workpiece. This is a cell mill with triangular carbide inserts. I'm running it 500 revolutions per minute and feeding 30 millimeters per minute. The depth of cut is 0.2 millimeters. That Uddeholm Sleipner was too much of an overkill. It is really tough material from the machining point of view. Since I need to make quite a deep pocket in this one, it would become such an ordeal that I wanted to avoid it. So I have a workpiece that is cut off from a really heavy slab of mild steel I have. This excuse of a workpiece is now going to be straightened. Angle grinder is not a precision instrument, as you can see. I am running the cell mill at 500 revolutions per minute and feeding 50 millimeters per minute. The depth of cut is 0.5 millimeters most of the time. Now that we have the workpiece in decent shape, it is milled down to final dimensions. The workpiece should be 30 millimeters wide, 30 millimeters high, and it should be 90 millimeters long. I am using my roughing end mill to remove most of the material, after which I wipe it clean with a normal end mill or the cell mill depending on surface. The roughing end mill is special in a way that it presents relatively low cutting forces even when removing a lot of material. The roughing end mill should be run relatively slow. In this case, I am running it 200 revolutions per minute with 50 millimeters per minute feed. The depth of cut is 3 millimeters with 4 millimeter step over. I could run it deeper if I had a beefier vise. I will now present a method to machine a deep pocket into a workpiece like this. This method is much faster than just plain milling the pocket. It is also easier for the machine and tools. You could make the pocket just by plunging in with a center cutting end mill and mill the pocket by going deeper and deeper until the pocket would be deep enough. This would be a time-consuming, tedious ordeal because end mills do not evacuate chips vertically very well. Instead, I drill suitable holes to the desired depth to have some room for the chips to go into. Here I have blued the workpiece in order to scribe lines for the holes. I am using a 10 mm drill for the holes and place them 10 mm apart. Conveniently, the final pocket will be 20 by 70 mm in size, so spacing with 10 mm grid is what is needed. Here I am using a center drill to make dimples to keep the actual drill from wandering around. I use the drill press XY table to get the distances of the dimples correct. My drill press has an adjustable quill stop which I use to keep the depth constant. To get the drill in place, I push it gently down and look how it moves when entering the dimple. I then adjust the table until I see no sideways movement. I drill 3 mm pilot holes first, followed by the actual 10 mm holes. Back to my milling machine to finish this pocket. I am using a 9mm high-speed steel end mill. The diameter is slightly less than the 10mm holes to accommodate the end mill comfortably. I am milling the full 20mm depth in one go. The chips need to be removed every now and then with the shop vac. I am doing this manually and by sight. There is absolutely no precision involved here. As the last step, I try to make the walls not that unsightly. Not that it would matter, as these are not normally visible. The quite large chamfer I'm milling with this dovetail cutter is there only for optical reasons. It creates an illusion of a properly machined part. I align the cutter by first touching the edge and then moving it inwards 4mm. This type of a cutter should be run slowly. This runs 200 revolutions per minute with 20mm per minute feed. Since my milling machine does not have power feed in the Y-axis, I need to feed those manually. There will be 3 holes to drill through this face. 2 are for the M6 cap screws and 1 for the intake fitting. The holes for cap screws are drilled here at the mill, and the intake fitting hole is drilled and tapped later in the drill press. The last operation for this part is the threaded hole for the intake fitting. It will be a M16 thread with 1 millimeter pitch. Well, that's it then. This manifold now, this one is, it's perfectly switched into place where it's intended to go, and already shortened the bolts for this, and yeah. So the main attraction, so to say, in this video is to how to make a deep pocket like that efficiently. You could use an end mill and go round many times, and that would be very tedious in a manual machine. But as I did, you can pre-drill a lot of holes suitably sized, and then you just go and mill the rest off. That's a lot easier for your machine, a lot easier for the end mill, and you also can go directly to the final depth with the end mill and do your stuff there. Oh, wow. So, that's it. And I think it succeeded well enough. Well, it's not perfect inside. There are some, because I did it by sight. I didn't measure anything. I just left enough in the edges so that you can see that it's thin wall enough, so to say. Okay, in the next episode of Finno-Ugric Machining, we are going to make or start to make the air oil separator. This is an essential part of this rotary vane compression, since the oil will circulate there, and you have to separate the air from the oil so that we have as little as possible oil coming out from the compressor. Easier said than done. I have a few ideas. I have been inspecting, studying a lot of documents dealing with this issue, and it seems like there is a common principle which is used out there. If you look after air or oil separator, you will see not very many designs. They all seem to be the same. for some reason. I don't know. Maybe the sheer volume of air when they are used is the reason why they look like they do. Okay, well, that will be in the next episode of window brick machining. Till then, bye!